To the next lesson for simple linear regression. In this particular recording, we're going to be converting everything that we just talked about into statistics language. And so we are using the same chocolate consumption and Nobel laureates scatter plot. And it has our imaginary regression line there, as well as kind of our delineation of the cloud. And so let's take a look at this with a new lens. So first of all, we need to talk about this in terms of our variables. Our x variable is our continuous variable, and if you remember back from geometry in high school, this line that goes across the bottom of the graph from left to right is called the x-axis. By convention, statisticians, if there is one that is a predictor and one is an outcome, statisticians put the predictor on the x-axis, and in simple linear regression, this is a continuous variable, so interval or ratio. And the y-axis would be the outcome variable. It also is a continuous variable, so interval or ratio, and that is by convention, that would be put on the y-axis. So anything that is the outcome, sometimes that's called the dependent variable, or could be the disease state, the health outcome, that kind of thing. This would be the health determinant, if we want to use the language of public health. And also, remember we talked about how with correlation, and this specifically says that it is correlation, this is only works if this best line is a straight line. And so if you think back to your algebra days or your geometry days, a straight line can be used that has an equation. And so if we have this straight line, and if we know some value of x, then we can predict y. So let's say that we were going to come along here to the number 5, and we find another country that is not on here, but they have a chocolate consumption of 5 kilograms per year per capita. If we go up to this green line and then trace our way across, then we can figure out what our best prediction is for that new country. And so we could do the same thing at 11, we could trace ourselves across, or at 2, we could figure out exactly what that particular straight line predicts for the y-axis depending on what we have for the x-axis. So in other words, if we know x, then we can predict y. Specifically for this scatter plot, if we know chocolate consumption, x, we can predict the number of Nobel laureates, y. And so this line has an equation that is y equals mx plus b. I think you probably are familiar with that, and now you're probably thinking, oh no, we're going to get into math, but this is going to be the easiest math lesson that you've ever had because it's going to make sense. And so remember that y, we've already defined that is our outcome variable, Nobel laureates. The x part here is chocolate consumption, because that's on the x-axis. We've already defined 2 of our terms, so the only things we have left are m and b. And I'm going to show you how we get to those. So what does this line tell us? Now we know we have a line. It has a mathematical equation, y equals mx plus b. In statistics, we rearranged that equation, y equals b plus mx. We've just traded those two. We can do that because of the property of addition. Y is the number of Nobel laureates. We already have determined that x is chocolate consumption. And so all we have left are the b, which is the value of y when x is equal to 0. In this particular equation, and m, which is the slope, and slope is simply rise over run. So let's dissect these two very systematically. I'm going to show you how to do the calculation for slope. Now, on any exam, including the ones in this particular class, you will not be probably, and I can't speak for the CPH exam or other exams, but you probably won't be asked to calculate slope. You will be asked to interpret slope. So if you understand how to calculate it, or if you watch me calculate it, then you will be able to understand what it means. that's probably more important than you memorizing an equation for how to calculate the slope. So you need to understand how we got this particular slope in order to be able to interpret what that particular slope means. So let's start at the beginning. Slope is equal to rise over run. And what I've done is for a couple of points along the x-axis, I've shown that if I were to go vertically up to the line, so for a chocolate consumption of 5, I would expect there to be 9, I'm just going to say this is probably about 9, Nobel laureates per 10 million population. If, on the other hand, I have a country that has chocolate consumption of 10 kilograms per year per capita, then according to this green line, I would expect there to be 24 Nobel laureates. Now, I'm estimating. I drew this green line. The computer did not draw it. So this may not be exactly what the actual regression line is, but this is the eyeball method. And so if you consider that the rise here from 9, if I go all the way up to 24, that is a plus 15. And the run for that same amount of slope goes from 5 to 10, and so that change is a 5. So from 9 to 24 is a 15, that's our rise. Our from 5 to 10 is a 5, a difference of 5, so that's our run, 1, 2, 3, 4, 5. And so our slope, rise over run, is 15 over 5, which is equal to 3. And that slope then shows how much y goes up for every 1 unit change in x. And so if I went from 5 to 6, I'd go from 9 to 12. From 6 to 7, I'd go from 12 to 15. From 7 to 8, I'd go from 15 to 18. From, where was I? From 8 to 9, I'd go from 18 to 21. And from 9 to 10, I'd go from 21 to 24. So for every 1 unit I change x, I go up by 3 on the y-axis. That's what slope means. So slope really is as simple as that. Rise over run. And you can do it for any value. You could try to do it just for 1. I'm not sure we would have gotten very good accuracy with that, so that's why I chose to do it over a longer period of the line. But in any case, you will not be asked to calculate the slope. I'm not going to give you a graph, have you draw a line, try to figure out what the slope is. Maybe I should, but you could do that on your own. You're going to have to know what it means. And so I've kind of alluded to that already. Interpreting the slope can be steep or shallow. So here's an example of a slope of 3. We go up 1, 2, 3, and over 1. So that's 3 over 1, so that's a slope of 3. Here's a slope of 1. We go up 1 and over 1, so 1 over 1 is equal to 1. And here's a slope of 0.33, or a third. We go up 1 and over 3. So rise over run is 1 over 3, or 1/3. So there's a slope of 1/3. And the take-home message, 2 of them, the slope can be steep or shallow, but the slope depends on the units for the x and y variables. If we have a constant x-axis variable and we report height in inches versus height in centimeters, our slope is going to change because it's dependent on the units that we report the x and y variables in. So that's one thing to consider if you're ever thinking about slope. Oh, that's a steep slope. Well, that's not a steep slope. It's very much dependent on the units that we have for these x and y variables. So here we have our example. We have slope is equal to 3 for our chocolate and Nobel laureates. For every 1 unit increase in x, y goes up by 3 units. So that's our particular example. I'm going to convert that to plugging in x and y. For every 1 kilogram per capita per year per capita increase in chocolate consumption, the number of Nobel laureates goes up by 3 per 10 million population. So see how I've snuck the units in here? So if I were to go up, if I were to start anywhere on this graph and go up by 1 kilogram of chocolate consumption per year per capita, then since this is a straight line, my number of Nobel laureates will also go up, and it will go up by 3 units. So that's the interpretation for our specific situation. But what I want you to remember is for every 1 unit increase in x, y goes up by how many units? So, and that's where our slope is. Y goes up by 3 in this particular case. Now here you'll notice I've specifically talked about an increase in x and y going up. What if the slope is negative? What that means is that y will go up by a negative amount. In other words, it will go down. And so it depends how you want to write that or how you want to remember that in your head. But I have included this 3 times because this is extremely important. I have never seen a CPH exam or any kind of examination situation where if you're supposed to understand about simple linear regression, this is not the question that they ask. So this is very important conceptually for you to not just memorize it, but to understand it. For every 1 unit increase in x, how much does y change? And if that slope is positive, that means that it goes up. If that slope is negative, that means that y goes down. But it shows the relationship between x and y. So that's the slope. The second piece of the equation that we were needing to figure out is b, or the value of y when x is equal to 0. Some people call this the y-intercept. I think that's probably a very good term. And so here we are, we're going to look at our very same graph, only this time we're trying to find out where this green line crosses the y-axis. And so what I've done here is we know that the difference between 9 and 24 is a difference of 15, and that's when we went from 10 down to 5. What happens when we go from 5 down to 0? Well, if it's a straight line, then this should also change by 15. It should go down by 15. What is 9 minus 15? The answer to that is -6. And if you see, it looks like this. I extended the green line, even though I said we should not extend it past our data points. It looks like that crosses down here somewhere around -6, because here's the 0, and so it's down below that. So let me show that not just graphically but numerically. And here's another, on an exam, you won't be asked to calculate slope. It's also unlikely that you'll be asked to interpret the y-intercept. You're not going to be asked to calculate the y-intercept. You're not going to be asked to interpret the y-intercept. It's fairly meaningless, except that it gives our line a location. And so we use it in the regression line because it is an important piece, but it's not important in terms of testing the hypothesis and understanding the relationship between the 2 variables. All right, so we're going to work backwards. If we change x from 10 to 5, so that shows this little blue line here, that corresponds to a change in y from 24 down to 9, or in other words, decrease of 15. Similarly, if we went from 5 to 0, in other words, x is equal to 0, when x equals 0, we would also decrease y by 15, same thing, so proportionately. When x is equal to 0, y is equal to -6, and that, by definition, is what the y-intercept is. It's the value of y when x is equal to 0. And so if we could find a country with 0 chocolate consumption, I imagine there are some countries that do. I would be very sad for the people who live there because I like chocolate a lot. But we would expect there to be a -6 Nobel laureates. Now you can probably appreciate the meaninglessness of having -6. It's not like those Nobel laureates appear and then they're snatched away. And so this points out the idea that the y-intercept can be a negative number. Typically in many health measures, that's kind of almost a meaningless measure. And so we don't put a lot of emphasis on what that y-intercept means, but it simply gives it a location. By location, I'll tell you what that means. Here I've drawn 3 lines that all have, I'm trying for a slope of 1. I'm not sure if I quite achieved that, but I'm trying to show you a slope that stays the same, but simply it crosses the y-axis at a different location. And so here, where x equals 0, y equals 1, in the next graph we have simply shifted the entire group, and so the line, the least fit line, also has shifted upwards so that it crosses at 2. And here's a third line, same slope, maybe similar data, but it crosses at a 3. And so you can see you can have the same exact slope. The y-intercept simply tells you the location of that line. It can move up or down. And so that is a location point. Slope is what tells you the relationship between the x and y variable. So in summary, let's look at all the things that we've done. Y equals b plus mx. We're going to give these some numbers eventually when we get to our output. So I'll point out what the b is and what the m is. The b is the value of y when x is equal to 0. Not very useful in statistics, but we need to include it in the equation because it helps us know the location of the line. M is where the money is. That's our slope. That tells us the relationship between x and y. It tells us the change in y for every 1 unit change in x. X is our predictor, y is our outcome. We might think of this as our health outcome and our whatever health indicator. These are also called, y is called the dependent variable, x is called the independent variable, and so they have a number of different names. And so that concludes this particular lesson. Next we'll be looking at how to perform a simple linear regression in SPSS.